Welcome everybody. In this video we're gonna verify the formulas for the derivatives of inverse trigonometric functions. So we have those three formulas to verify. We're gonna start with the leftmost one. So it's the derivative of arc sine x, which should end up being 1 over the square root of 1 minus x squared. So we actually start with equation y equals arc sine x, and what we're looking for the formula of dy over dx. But since we don't yet know the formula for derivative of arc sine x, so this is what we're trying to derive, we apply sine to both sides of this equation. We're going to have that sine y is equal to sine of the arc sine x, and sine of the arc sine always simplifies to be just x. So we actually have equation that sine of y is equal to x. So now this form of the equation we can do derivative of. So we do implicit derivative with respect to x of both sides. So we have derivative of sine y equals derivative of x. So derivative of sine y is going to be cosine y times dy dx. All of that is equal to 1. That's what derivative of x is. So if we divide out and solve for dy over dx, we get that dy over dx is equal to 1 over cosine y. So to bring it to better form, we use the identity sine squared y plus cosine squared y is equal to 1. So cosine squared y is equal to 1 minus sine squared. So solving it for cosine y, we see that cosine y could be equal to positive or negative 1 over, rather positive or negative square root of 1 minus sine squared y, which is positive or negative square root of 1 minus x squared. Since y is, well, since sine y is the same as x, so sine squared y is going to be x squared. Okay, so now to choose what actually happens, we see that cosine y is the same as cosine of arc sine x, since y is arc sine x, and cosine of arc sine x is always a non-negative quantity. So out of those two signs, only the positive one makes sense in this situation. So we have that cosine y is actually equal to square root of 1 minus x squared in this context. And then we have the formula for dy over dx, so it's 1 over cosine y, which is the same as 1 over square root of 1 minus x squared. So we verified the identity we wanted to see. Okay, so now looking at the derivative of arc cosine, we proceed in a similar fashion. We start with equation y equals arc cosine x, so we're trying to find formula for dy over dx. We apply cosine to both sides, simplify cosine of arc cosine to be just x, and then differentiate both sides using implicit differentiation. We obtain that we have negative sine y times dy over dx is equal to 1. And solving for dy over dx, we see that dy over dx is equal to 1 over negative sine y. So again, solving the Pythagorean identity for sine squared y, and then taking the square root of both sides, we see that sine y is equal to positive or negative square root of 1 minus cosine squared of y. So it's positive or negative square root of 1 minus x squared. So then we do the similar simplification. So in this context, sine y is the same as sine of arc cosine x, and it's again a non-negative quantity. So we have that sine of y is going to be the positive square root of 1 minus x squared. So out of the two signs on this line, only positive sign works out. And since sine y is the square root of 1 minus x squared, the dy over dx ends up being 1 over the negative square root of 1 minus x squared, which, if we pull the negative in front of the whole fraction, is the formula that we expected. And again, it's essentially a very similar derivative, but the derivative of the inverse cofunction has a negative sign here. So that's an easy way to remember it. And for the third formula, we're doing derivative of arctangent. So we'd like to see that it ends up being 1 over the 1 plus x squared. So again, we start with y equals arctangent x, apply tangent to both sides, and then tangent of arctangent of x simplifies to be just x. So we have tangent of y equals x, do implicit derivative of both sides. We have derivative of tangent y equals derivative of x. So derivative of tangent y gives us secant squared y times dy dx. On the right, we have derivative of x, which is 1. Solving for dy dx, we see that dy over dx is equal to 1 over secant squared y. So if we use the identity, 1 plus tangent squared y is equal to secant squared. And we can rewrite it as secant squared y equals 1 plus tangent squared y. Since tangent y is the same as x, we see that secant squared y is exactly 1 plus x squared. We don't even have to do square roots. So derivative of y with respect to x, which was 1 over secant squared y, ended up being 1 over 1 plus x squared, which is exactly what we wanted to verify. Derivative of arctangent is 1 over 1 plus x squared.